So in addition to the tree that we built last time, AhoCorasick is going to use fail relationships between the nodes. And to generate these, to start the algorithm, we're going to assign each of the children of the start node, or the root node, are going to fail to the root node. So we're going to denote that by a dotted line, dotted green line. So each of the root's children fail to the root node. And all the fail means is that when this is trying to match a character, when we're traversing through the tree, when this is trying to match a character that it doesn't have a child for, it's going to fail to its fail node, and then that node is going to try to match that child, or try to match the next character. So how the algorithm is going to work is each of the children of the root node are going to fail to the root node, and then we're going to add these children to a queue. So we're going to add A and add B to a queue. Now essentially what we're doing is we're doing a level order traversal and building relationships as we go. So we're going to do is we're going to pop out this first node A. And now this is going to be our current node. And we're also going to have a variable for our fail node. Well, that's just denoted by this green line. And now for each of its children, we're going to do the following. So this is going to be the first child. So for each of its children, we're going to look for the closest ancestor, starting at the fail node, that has a child with this character. Okay. So again, for each of the current node's children, we're going to look for the closest ancestor starting at the fail node that has the character of the child. So, if you'll notice here, we're looking for character A, for child A starting at the fail node. Okay. So from the fail node, you'll notice it actually does have a child with character A. So this node is going to fail to that child. Very nice. Okay? Now, for each time you set a fail node, you also add the output of the fail node. So this A, you're going to add the output of the fail node to the node that you just set the fail for. So this node is now going to be able to output A as well. And all that's saying is that A is a word in our dictionary. So if we are at this point inside the string, then obviously we've matched the string A. Okay. So now for the next child. So for the next child of our current node, we're going to say, starting at the fail node, we're going to look for the closest ancestor that has child with character B. So fail actually does have a child with B. So this node is going to fail to that child. All right, and as we continue, now you can see that all the children are done for our current node. So what we're going to do is, in doing a level order traversal, we're going to add both of these children to the queue. Okay? So AA and AB. So now we're done with our current node, so we don't need that variable anymore. So what we're going to do is we're going to pop out the next node out of our queue, B. So now this node is our cur, and we have a variable for fail, for the fail node of the current. Now for each of its children, we're going to look for the closest ancestor starting at the fail that has character C. Now, in this case, the root node does not have a child C, and we have nowhere to fail to, right? There's nowhere to go up from the root. So this node is simply just going to fail to the root node. Okay? That means that there's no previous there's no characters, there's no nodes on previous levels that have value C. So this is going to fail to the root node. For the next child, we're going to do the same thing. We're going to look for, starting with a fail, a child D. It does not have a child D, and it has nowhere to fail up. So D is also going to fail there. Now you'll notice I didn't add any output because the output of the root node is just the empty string. So all I'd be saying is that C can output BC or can output the empty string, which is semi-meaningless. So we are done with B, so what we're going to do is add both of its children to the stack. So BC and BD. We're not done with this, so pop the next node out of the stack, AA. So we have cur, and we have our fail node. Go. So for each of its children, we're going to look for the closest ancestor, starting with the fail node that has character, or child with character B. Okay. So you'll notice the fail node has a child B, right? So this node here is going to fail to that child. And when we set a fail, remember that we add the output. We add the output to the child, or the node that's having its fail set. So this AB is going to be added to this output. And you'll notice that all it's saying is if I've seen string A, B, then I've also seen string AB or AB. Right? Okay, so for the next child, we're going to start at the fail node, and we're going to look for child C. Okay. This does not have child C, so what we're going to do is we're going to fail up. Okay. So now we're going to take our fail. So our fail is up here, and we look for child C again. This does not have child C, so just like we did in these cases, this is going to fail to the root node. Okay? Let's see. The least confusing way. Okay. So C is going to fail all the way up to the root node. Now we're going to add, since we're done with this current node, we're going to add the children to the stack. So, to the queue. So we're going to add AAB and AAC. And we can get rid of this variable. So we're done with AA. So we're going to pop out AB. So AB has no children. We're done with AB. Pop out BC. BC has no children. Pop out BD. BD has no children. AAB has no children. You get the idea. AAC has no children. So we're done. So we have successfully built all the fails for this tree.